Thank you. And the small talk really helped me me to get comfortable. Yeah, I'll start now. Um, so what does the future of programming look like? Is it all LLMs generating terrible, unmaintainable Python scripts? What do you all think? So that's an open question for everyone.
Well, I mean, they'll be hallucinated Python scripts. We don't even know if they work.
Mm-hmm. Anyone else?
I don't have strong thoughts. I'm still trying to figure it out, and I've seen I've seen both sides, right? Like I've seen people like, oh, look at this PR. Um, yeah, this is a funny one, right? Someone said, I think they use Cursor. Right? Cursor generated it 100%. And then it's like with my help, I was like, okay, if you, with your help, then it's not 100%. So what percent is it? But it's like then it's a relatively small PR, and I looked at it, I was like, okay, it's fine. But I was I'm more curious like when I do a PR that's like non-trivial, like just and I don't want to just like have Cursor do it, look at it, and it's like, okay, it looks good. I kind of wanted to see, okay, what would I do versus what they did. So like what an experiment I did is I actually have this PR, actually this work that needs to be done. I wrote it by hand first, no AI. So I have a PR there. Then I basically switched back to the master branch and then basically had AI do it again. I basically using relatively clear instructions, I think, and compared the two. And I thought AI did okay. I ended up still well, this is in progress. I ended up probably still will use my own thing. I suppose another thing is I can keep directing AI until it get to closer to what I like. But at the end, it didn't like what I was hoping for is for it to introduce good insights. I was like, oh, I did it this way, but I could have done it so much better differently, and I did not get that in this case. So yeah, so I think I'll probably maybe do a couple more of that kind of experiment and then see where I end up on. But the other thing also is that we've got a cursor license at work. So I played with that a little bit. We also have a ChatGPT license. I kind of want to try and play with that a little bit as well. Maybe Codex, I'm not sure yet. And the other one is, yeah, I also tried like running models locally. So I kind of want to try using, like I know JetBrains AI. We are at work, we're not allowed to use JetBrains AI, even though I've got a personal license and I know I can. But for work stuff, I will just try connecting local models only and kind of compare and see like basically what it looks like, right? And my hope is that it would provide insights. One thing I've seen that's somewhat useful is to use like something like GitHub Copilot to do code reviews for me to find stuff. But at the end of the day, I haven't been super impressed yet, but I'm still trying to. But I do know also that from our, like as I mentioned earlier, from our executive level, everyone is like, okay, you are using AI. So yeah, and then but then I had that question that you asked earlier, right? Like so AI, from what I've seen, right? Like the people who seem to like to talk most about how great AI is are like the founders who's like, hey, I can start my company with hiring no engineers or whatever. But I always wonder, right? If that business becomes successful and you are the first engineer, like what are you getting yourself into? I'm very curious about that. Would it be maintainable code, or would you be like, no, I'm rewriting all this because there's no way? So I'm very curious about that, and that's partly what I'm trying to find out for myself. Anyway, sorry, I probably talked too much there.
Oh no, very good answer. Very well put. Do we have someone else as well to speak about, what does the future of programming look like to them? And if they experienced LLMs and maybe generating some terrible, unmaintainable Python code at work. So Okay, should I start? Okay, so LLMs are changing the world, whether it is for the better or not, that's up to us. And with this, I welcome everyone, and I'm very happy to have you all here today as we embark on this exciting journey into the world of Gen AI. And we will explore LLMs and we'll see how they can help us write structured, maintainable Scala code. And Scala has so much potential in AI driven development. And in this talk, we are going to uncover why it's a game changer. And before I start, I would love to give a big shout out to the host. And thank you for creating this amazing community. And let's deep dive into this topic and spark some great conversations around the future of software. Thank you again, and let's get started. So, it's time to set the stage now, and Gen AI, particularly LLMs, is reshaping industries. And it's doing that by making complex problem solving more accessible to anyone and everyone. So, we all know by now that AI is advancing rapidly with LLMs at the heart of this revolution. And these models, they are driving automation basically in coding, decision making, and natural language processing tasks. But in the world of AI development, like I said, Python has been the dominant language. And why is that so? What I can think of, and based on my research, it's because for a long time, Python has been the language of data science and ML enthusiasts, and it has a vast ecosystem of AI ML tools. However, Python is not without its shortcomings. Like someone just spoke. So some of the shortcomings include lack of type safety and lots of runtime errors and scalability issues being some of the really biting ones. And we all Scala developers know that Scala is a better language for building tools, and it should have a prominent role in AI development's future. And if we question, can LLMs generate high quality code? So we will argue that Scala, due to its strengths, is the right target language for LLMs to write code as well. So can LLMs write production grade Scala code? That's what we are here to figure out. And with that, I will move on to a slide about me. And given most of this I've already covered, I would like to move past it. But yes, and I'm a Scala developer, and yeah, that's all I would go about with this slide. And we'll move on to the next one. So here's our roadmap for today's discussion. And we'll start with a brief introduction to Gen AI and LLMs. And next, we'll explore how software engineering agents work in a bit of detail. And then we will have a discussion about why Scala is uniquely suited for AI-driven development. Moving on, I will introduce what LLM4S is, which happens to be a Scala first AI toolkit. And by the end, I hope you will walk away with a fresh perspective on AI in Scala. So, time to deep dive into how LLMs actually work internally. So, LLMs in very simple terms can be thought of as word guessers. So given a sentence, they try to guess what the next word should be. For example, when I say once upon a, so we all know it's like the story goes like once upon a time. We have all read about this in various storybooks. So it's all about what comes next, sort of predicting the next word, next line of code. So LLMs are surprisingly good at this. And they are in fact so good at the next word prediction and storytelling that we can even get them to write code one word at a time. So yeah, this is pretty surprising from where we were a decade back, building software. So modern LLMs like OpenAI's GPT or Anthropic's Claude, they are trained on massive amounts of data, and they use these deep learning techniques to generate almost human-like responses. And they can be used in various ways, such as the first one being zero-shot prompting. So what zero-shot prompting means is like it's the ability to perform tasks without prior training on specific examples. And LLMs can also be used in some other different ways, like few-shot prompting. So few-shot prompting is providing a few examples to guide the model towards better outputs. So these approaches rely entirely on the input prompt and, of course, the model's pre-trained knowledge. And we can go further by giving LLMs the ability to interact with the world. For example, by calling functions or APIs to fetch information or perform actions. So this is, we all know, called as tool calling basically. And by allowing the LLM to actually converse with the environment, like we devs talk with each other, we can begin to build an agentic system. So that's what's the core of an agentic system is, where the LLM not only responds in conversation, but also takes actions. Think of it like a conversation with a support agent, where a user is saying that my laptop is broken, and the LLM is saying, have you tried switching it off and on again? And it's sort of giving a prompt to take an action. And then when the user says, let me try that, and it's working now. So LLM is responding like, great, have a good day. So these agentic loops are incredibly powerful, and they enable LLMs to solve a wide range of tasks, from generating and running code, making database queries, and calling APIs, to debugging errors and optimizing workflows. So I know this all sounds like what we do at our day job. But here's the question. How do they perform all of this in a strongly typed language like Scala? And yeah, let's explore that next. So let's focus specifically on LLMs creating software. AI-powered development has, of course, come a long way, and LLMs can assist in writing software at different levels of complexity, which I'll break it down now. So first, there is the simplest level. Like if I ask a LLM to write me a function that adds two numbers, it can do that easily. It generates a basic function, understanding the syntax and logic, but without much context, of course. Next, we have Copilot. We all are now very familiar with tools like GitHub Copilot, and these work like These are like supercharged IDE autocompletes who predict and suggest the next few lines based on the local context. So they make coding more efficient by reducing the boilerplate and caching patterns as we write. And they are the ones that when we add as plugins in IntelliJ, they suggest the code pop-ups like insert me based on what problems we are solving in the IDE. So I have been using that insert me in a lot, like based on the suggestions. They're not always correct. I've seen that. And it makes me question what I'm writing. But yeah, moving on. We have the third level called agents. This is where things get really, really interesting. Unlike the co-pilot, agents don't just predict the next line of code. We are way beyond that. They actively solve problems. You give them high-level instructions, they analyze the entire code base, interact with API, generate multiple functions, debug their own output. So they will also be logging all of this, whatever it is they are up to. So they don't just assist, they take ownership of the solution. So if you see logs of an agent at work, you can see how it actively records everything it did with great logging ability to track back by a human if needed. So what's the key difference? Co-pilots work on a local level. They guess the answer from local context, small snippets such as the file you're working on. Agents, on the other hand, they operate at a global level. So the only difference is the level. And they can explore the entire code base, understand bigger context, and make structural changes to the code. Then, of course, run them, actually test them. And this is what we are experiencing as the game-changing ability, which is uplifting from the previous steps, like the other two levels that we just saw. So how do we make these agents build software? Like what's internally going on? So let's talk about the new cool tool, software engineering agent. And just like you, the agent has a set of actions. It can take tools and it works in a loop, as we discussed earlier. So if you look at the diagram, at the most basic level, the core tools are find, read file, write file, and run command. So if you focus on just these four tools, find, read file, write file, and run command, these appear as the most basic level core tools. And this is what an agent actually works on. Now imagine I gave you a Unix shell with just find, cat, and sed command, and of course the ability to run commands. Could you write software with that? Sure. Would it be slow and painful? Definitely, but it works. And here's where the magic happens. LLMs can do the same thing. Given just a few basic tools, they can start building software. So how do we actually make it better? So moving from V0 to V1 architecture, if all I gave you to solve problems were just find, cat, and sed, sure, you could write software, but it would be slow. So let's give the agent more tools. First, of course, a very safe space to run the code. So who here has accidentally run rm-rf at the wrong level? I know I have. And if I can't always trust myself, can I really trust an LLM with something like that? So that's why we run the code in a container. And next, let's give LLM some more information. So we have a safe space to run the code, which is our container. So if you look at the diagram in the environment, we can see I've mentioned the code execution environment. So giving LLM more information like prompts that include, okay, what are our coding standards, best practices. Then more information beyond prompts, we can give like an outline of the entire repository. So it's not starting from scratch every time. It's about the context that I was talking in the previous slide, the global context. Then what else we are giving LLM? A working memory to keep track of all the progress and context, because as a dev, we have all of that in our head, right? So yeah, we have to give a working memory to the agent. Now let's give it even more tools. MCP for the win. Tools like Git. So Git will let it manage, of course, the version control. Then we are giving it web access to search for documentation or examples. We are giving it web control, example Puppeteer to test the front end. We are giving it database readers to query data and check state. And the list goes on. It's nearly endless because we have tools for everything nowadays. And that's really all you need, a SWE agent. So a key innovation in AI-powered development is the SWE agent architecture. So think of it as an AI agent that can write, test, and refine its own code. And how does it work? The agent operates in a containerized workspace with access to tools and these test environments. It iterates like humans do. What do? We take instructions, we write code, we run tests, we observe results, and then we repeat. We keep doing it. And what makes it beautiful is it includes a self-reflection mechanism where it learns from the errors, improves tests, and enhances code quality over time. So if you look at the diagram, this is where I'm focusing on the loop. Now getting agents to generate Scala helps significantly because it gives more immediate feedback, such as type errors. So that's the beauty of Scala there. So this whole approach can be summarized simply. Fail fast, fail early, and of course, speed up the development life cycle. And we'll look at the architecture now, the Scala way. Can we even do better than what we just discussed in the previous two iterations? So like I told, LLMs live on context and information is the king. So when it emits a Python script, maybe you can run a 𝗪𝗽 or black or rough to try and find errors. But wait, we can do better. Scala gives us types and errors and consistency. If we write Scala and include compilation in the feedback, we give the LLM much more accurate information to work with. Now, adding Metals MCP, we can provide the LLM with accurate symbol search, etc. So getting these agents to generate Scala will help the agent do its work by giving more timely feedback, better feedback. Example, all these type errors. And this approach can be described in simple words, like I said before. Fail fast, fail early, of course, speed up the development life cycle. So what we believe that in the long term, this will provide the best environment for agentic coding. So that's what I'm trying to take you to by walking you through these different architectures. So how do we measure the success of an agent? So that brings us to the concept of a SWE bench. Let's take a quick aside. How do people actually measure how well these agents are doing? So SWE bench is a way to benchmark the performance of software development agents, specifically for Python related tasks found in GitHub issues. So yeah, all of this was initially created for Python because of course that has the whole ecosystem. Now, what it provides is a standardized framework for evaluating how well these agents handle real world issues that developers face. The set of issues used in SWE bench is focused on Python code problems, and that's why the evaluations are limited to this domain. So there are agents such as Aider, OpenHands, and Agentless, and some of the top contenders these are like some of the top contenders that have been tested using the SWE bench. So the SWE bench is useful. It's worth remembering that it only looks at a subset of possible issues, meaning that these agents might perform differently in other scenarios or on a broader problem set. So we know that these agents don't generalize very well yet. I'm sure this is something we all as developers can agree on, that they can solve issues, but they are far from perfect. So as you can see on the leaderboard here, the performance of these agents is compared based on how many of the test issues they are able to actually solve. So they take a GitHub issue and the code base and attempt to generate the right software change. So biggest wins so far are when the LLM gets better. The tools still have a long way to go, of course. And if you go check this, Claude 4 is visible on the dashboard. It just got released 2 weeks back. So here's the call out to the audience. We all know that Scala is a fantastic language for building robust and scalable software. That's exactly why we all are here today. So whether we are using Scala for backend development, for big data, for distributed systems, you have experienced its power firsthand. But here's the challenge. While Scala excels in many areas, AI and ML tooling is overwhelmingly dominated by Python. And why is that? But most importantly, can we change that? So let's dive into why Scala deserves a place in AI development and how we can bridge the gap with modern LLM techniques and how projects like LLM4S, they are paving the way for structured type-safe AI solutions in Scala. And let's explore this together, why Scala should be at the forefront of AI innovation. So, like I said, Python is dominant in AI, but Scala offers unique advantages for AI-driven development. And building AI tools in Scala is better. And you know this already. And I don't even know why I have a slide. But yeah, just kidding. Why Scala is a great target language? So I know I've said this a few times. I hope as my audience you saw that pattern. So the answer is it's all about the context. Providing LLM tools and information. For example, types to provide checks to the code, then metadata, like what parameters are valid here, then errors. Compiler provides high quality error messages. and a very, very rich library ecosystem. And yes, of course, fail fast, give good feedback. This is what a typed language gives you. So Python people are so desperate for this that they now have 𝗙𝗵𝗁 or MyPy and rough to try and enforce things built into the language. So they don't have it all in their language, and they are trying to enforce those things which Scala naturally gives you. And introducing LLM4S. Of course, a very, very new Scala first AI development toolkit. And this project aims to bring structured type-safe AI development to Scala. And here's everything that it will offer. Starting with structured AI workflows, ensuring AI-driven applications follow predictable, maintainable patterns. Then, tool calling and API interactions. So it will provide seamless integration with external tools like APIs and databases. Third one being multi-step workflows, supporting iterative development and feedback loops, similar to Python's LangChain. And fourth one being agentic workflow framework. And fifth, Scala native AI development, leveraging Scala strengths to improve reliability in AI workflows, both in tooling and in code generation. So this project is in active development at the moment. It was announced in February in San Francisco, and we are still building it. It's also part of Google Summer of Code program 2025, where Google is funding for 4 interns to work on this project. And LLM4S is still evolving, but it promises to make AI development in Scala more accessible and efficient in multiple ways. So to wrap up, let's recap what we have covered. So I talked about how LLMs are very powerful, but current AI tooling is heavily Python-centric. Then I moved on and explained how Scala provides better type safety, reliability, and maintainability, which is very important for AI development. And building AI and getting AI to build software. And we believe that Scala is the right target language for LLM software generation. There is a lot of work to be done. Come help us prove it. Then I spoke about SWE agent architecture, and I spoke about how it enables AI-driven software engineering with feedback loops. And the last thing, of course, LLM4S, which is a promising Scala-first AI toolkit that brings structure to AI development. So what are the next steps? Get involved. So whether you are a Scala developer, AI enthusiast, open source contributor, we encourage you to explore LLM4S and help shape the future of AI development in Scala. I encourage you to explore the project. I had this link in lots of my posts. So think about what a type-safe AI ecosystem looks like, and all the rush and chaos that we see, especially those who have experienced working with it in Python-based environments. I'm sure as Scala developers, you must have worked on different languages, and you will experience that chaos soon if you haven't. So we have to think how we can push the boundaries of AI in functional programming. And if you are interested in contributing, of course, check out the project on GitHub. There's tons of open issues. We have built a community around it. And yeah, join us in building this type-safe AI-powered Scala ecosystem, and we welcome everyone. So yeah, if you like this, of course, please start the project on GitHub. And something about the maintainers. I would like to take a moment to introduce Rory Graves. I'm sure you know a bit about me now, so I'll talk about Rory. So he's a Scala expert with over 30 years of experience, and he has made significant contributions to Scala compiler optimization and AI-driven research. He has been doing something similar and has been experiencing things related to this at his day job as well. Given all the work he has been doing in AI-driven research, and a huge thank you to Rory for being an amazing co-maintainer on this project and for his invaluable contributions to creation of LLM4S, and for, of course, giving me the opportunity to work alongside him in maintaining it. And we are very delighted to connect on LinkedIn to discuss the project further, and we look forward to collaborating with you. And if you are interested in exploring LLM4S and discussing topics related to open source and Scala and AI, so you can, of course, join our community. And this image is from Scala Open Source Hack Night in London, where we actually brainstormed and discussed the project. And this is something from Jan 25. And here are some resources to further explore the fascinating world of LLMs and intelligent development and agentic programming. And these links provide insights into, of course, the cutting-edge AI advancements, evaluation frameworks, and open source projects that are really pushing the boundaries of Gen AI. Yeah, I encourage you to check them out. And of course, continue your learning journey beyond today's session. I'm sure you must have gotten something out of it. And thank you again for being a fantastic audience. And of course, I'm open to all the questions, and feel free to reach out.
Yeah, thank you so much. Well, I'm going to open it up to QA in the audience. Well, I know, so while other folks are thinking their questions, I know I have a question. Can you show us the website? I actually didn't look up LLM4S before I joined. So do you have anything like a quick demo, or like, you know, is it a project that I download? Is it something I incorporate into my own code base? I still don't have a great sense of what LLM4S is.
Okay, I will start with giving a GitHub link of the project in the chat. And so basically, here's the LinkedIn post that I have created, which has the link to the AI community we are building as well. So if you click on the post, it will, on the very first line, it has the community link. And yeah, to answer your question, Mark, so the project is very new, and all the features that I spoke of, we are still building those features. And I am working on talking about what and why of the project at the moment, and how we, like you saw in the talk. So yeah, once we have some of the features deployed, hopefully by Scala Days, I and Rory will be presenting a demo there, and at least some features out for you to incorporate and try by yourself. So yes, that's how it looks forward. That's
okay. What features are you prioritizing?
For now, we are working on very basic things. We are actually trying to involve a lot of people around the world by talking about what we are doing. And based on that, we are getting a lot of community feedback about the features. So if I click on the link, and I will just quickly share my screen. So those are some of the features I spoke about in the talk as well. And like I said, we are in very, very early phase. So there's some part of development done for some features. And given it's a community-driven project, it's not like we are focusing on this or that. And because there's a lot of people working on different things. So yeah, everything is sort of in a build phase. I'll be able to comment like more on that when we are actually able to, finish one of those completely, because when there's multiple things in development, I can't talk about what is it that we are going to demonstrate in the Scala Days conference. But yeah, whichever it is, we are able to, get success with. Yeah, that's what it's going to be. Because yeah, it's project is evolving. So
Tamaz in the chat asks, is it a project to integrate LLMs into projects, or something that can be incorporated into IDEs to generate Scala code?
So the more of first one, but the second one is something we can look about to adding as another feature, another layer to what we are building.
So be putting a type-safe wrapper around, I guess, the API for an LLM. That makes sense. Which LLMs have you guys experimented with then? Are there any that are particularly suited for putting a type-safe API around?
So at the root, we are exploring multiple, and I think this has already been. This is something Rory has already incorporated in the project. So there's various LLMs we are taking our inputs from, and there's also an opportunity to switch between them. So all of that integration has already been put forward. Yeah. So when we are basically developing and testing things, we can also switch it and see what's doing better and sort of compare. Yeah.
So if folks have questions, feel free to post them into the chat. You can also raise your hand if you want to ask a question in person. So.
Yes. Yeah, that's correct. So I would like to mention it here that, of course, it's built in Scala language. But yeah, it's also going to create a lot of good Scala code for us to help with our day job. So when I announced the project in the Bay Area Scala conference, I had these conversations with people, and we were talking about all of the things that they have tried in the in the space to see like what kind of Scala code AI is creating to help them with their day job. And given most developers are working with multiple languages, even I worked with Scala and TypeScript as well at my day job. So a lot of them had the similar feedback with that it's not able to create very good Scala code. And I attended a talk about the IntelliJ plugin for creating Scala code, the insert.me that comes, and I have been doing my daily lead coding and practicing for my skills, and it keeps giving all these suggestions, and of course I do go about them sometimes, but it's actually generating a lot of wrong code and suggestions. And of course I constantly second guess my own my own code, and I compare it with it. But now, because I've seen a lot of bad code being produced, and I got the similar feedback from the community of people who have tried this, and I've tried it myself as well. So yeah, I think it does make sense, and yeah, with LLM Forest we'll be able to create better code. But yeah, from February to now, what's June? There's a lot of improvement in the existing models too. So with Claude's latest version, I think it is also getting much better. So yeah, that's also there.
Yeah, I've probably been playing the most with AI. I didn't really touch it until really the last 3 months or so. But I've tried it in a couple of different scenarios. There was a situation where I needed to work with GStreamer for something, and I found that really useful because I was able to generate actually working GStreamer pipelines relatively quickly because I needed to iterate on that. And the documentation around GStreamer is quite bad in a lot of ways, so that it could just sort of tell me what it was that I needed to write without me having to learn the entire syntax of what a GStreamer pipeline looks like. That was incredibly helpful. And then I also used it to generate command line arguments for a thing called 𝗪11 Docker. One of the projects that I was working on was I wanted to run an application in Docker, well, in relation to GStreamer in order to capture video output. And so I had it generate command line arguments for this 𝗪11 Docker application that will fire up a full 𝗪11 environment inside of Docker. And this is where I ran into, I mean, it was not perfect on the GStreamer stuff, but it very clearly was hallucinating. And I was using Claude, hallucinating command line arguments that never existed, that couldn't possibly, well, if they existed, it gave you what they would have looked like, but they just didn't exist. And so that's where, it really became clear to me, like, yeah, this isn't, there's no factual database right now for a lot of these things in the back end that it can check against. It is just purely this token thing where it knows what the shape of what to generate, and not necessarily a lot more. But I had much better luck when I was asking it to do some SQL stuff that was well beyond my SQL skills, but I could describe what I wanted it to do, and it did that almost perfect with 0 errors. It was great. So, and I kind of wonder how Scala would work, because you have to have a fairly large training set, I feel like. And with things that are a little bit more niche, I can see that being a problem. So.
Yeah. So yeah, as Pavan has raised in the chat, I agree with this. Like, how we are sending the prompts heavily influence the way it responds. And yeah, Claude's 3.7 and even 4 were outstanding for Python. And yeah, I've had this discussion with Rory as well, because initially we were using some other models, but lately we have been using a lot of Claude for developing LLM for us. And yeah, even we are surprised by its capabilities.
Yeah, I guess I did try and generate some Scala last year. No, it was earlier in the year. It was earlier in the year. Yeah, that works fairly well.
Yeah, I highly recommend using it.
Yeah, I needed something fairly simple, and it did a good job of that. So I was quite happy.
So I'm also, beyond this project, I'm also working a lot on, so I have a very good background with working on big data and all the data related things, and that's how I got into using Scala, and that's how I was really impressed with the language and I fell in love with it, which was, yeah, a long time back. And so because I have all of the data experience as well, lately I have been trying all the, so there's Meta's model, 𝗪𝗪𝗻 something, and so yeah, I'm working on that, and we are seeing like how using AI models, even creating the data pipelines and everything everything that we did in the data space. So how that's evolving as well. So yeah, with this, I know I spoke more on the backend side of things with the examples I gave, and because it does resonate with my day job. But yeah, I'm pretty impressed with, given a lot of people are using Scala with their data jobs, and in London, there's no distinction between the two. People are doing both in the same team. So yeah, I'm very impressed by its capabilities in the data space as well.
Yeah, it makes sense. Well, do other folks have any other questions? Otherwise, I think we're going to wrap it up for tonight. Going once, going twice. All right, then. Well, thank you so much for presenting tonight, Kannupriya. Yeah, this was a wonderful talk. Thank you so much. Thank you to everybody who was able to join us tonight. I don't know what we have coming up for next month. I don't have anything planned just yet. I think I'll be around. Oh, actually, I might not even be around. We're taking a big road trip the first 2 weeks of July. So actually next month might end up being canceled. I better look at my calendar. But we'll see. We'll definitely be around back in August for sure. So, all right, cool. Well, and with that, I'm going to drop off. Have a good night, everybody. Thank you for joining us.
Thank you all.
Thanks all.